Okay, I want to thank everybody for joining us for today's session, brought to you by Asterix and presented by TetraScience, entitled Overcoming Lab Data Inertia, Learnings from a Decade at the Bench. Again, presented by TetraScience. We can go to the next slide, please. So before we get into today's session, I want to explain a little bit about who Asterix is. And, we've been kind of sponsoring and presenting this webcast series now for coming up on a year, and we've been bringing in companies from all throughout the lab informatics and lab technology space. But who is Asterix in relation to that? If you're not familiar with who we are, let's give you a little bit of background on what we do. We're an informatics professional services and strategic outsource solutions company. We are dedicated 100% to serving the scientific community. A couple of quick stats about us. We were established back in 1995 and are privately held. The company originated out of an IT division of APBI, which is a life science research organization. Today we operate from 7 offices in the United States and beautiful Costa Rica, and we headquarter ourselves in Red Bank, New Jersey. In terms of the type of companies that we help and the type of companies that we work with, Fortune 1000 life science enterprises, the big pharma, biotech, chemical, CPG, any government research institutions, generally speaking, companies that are going to have large or fast growing IT needs, outsource needs, or compliance needs. And our mission has and always will be to deliver scalable, sustainable solutions for the scientific community. And what that means, we can go to the next slide. What that means, the type of solutions that we deliver are meant to span the complete life cycle of scientific data systems. And what that means is, typically in the beginning, we're helping companies through business process analysis and enterprise architecture. Laboratories may not necessarily be, a huge IT organizations with lots of IT skill sets on staff. So we can kind of come in and help them understand what is the right technology stack, what is the right technology deployment type, should you move to the cloud, et cetera. So there's all these decisions that need to be made about the type of technology that you need to efficiently and effectively run your R&D in your lab. Once we do that, we can actually get into selection services and then also development and implementation of solutions. We're technology agnostic. We don't align with a particular vendor in the space. We try to maintain neutrality and have good understandings of many of the vendors in the space so that we can make unbiased recommendations. And then if needed, we can certainly help with development and implementation, and then we can certainly help, and we often do, with computer systems validation at the end. From there, we can provide a host of services after the fact. We can, basically be a resource ongoing for making sure these systems are upgraded properly, that you have proper training, that you have proper resources, and we can even staff individuals into your laboratory, technical and scientific resources. So there's quite a bit we do, evaluate, implement, manage systems, all to, hopefully enhance and solidify the collection and processing of scientific data. That's enough about Asterix. We wanted to, again, give you kind of a quick overview of who we were. I want to obviously now turn it over to our speaker. So let me take a moment and introduce our speaker for today. Joel Melby is a PhD life sciences and data analyst. He spent 6 years at GSK, GlaxoSmithKline, in both technical and scientific roles. And during his time at GSK, was able to accelerate scientific discovery by automating data visualization and analysis to enable data-driven decision-making. So with that, we're thrilled to have you, Joel. I'm going to go ahead and turn the mic over to you now. I'm going to sit back and enjoy the presentation with everybody online, and I'll come back on at the end.
All right, thanks a lot, Kevin. So today I'll be giving you really my perspective on data. And as the title suggests, right, I spent a decade at the bench. I worked at a big pharma company. And so I'm really gonna kind of use that as the lens to talk about the TetraScience Tetra Data platform. And before I really jump into it, when we think about the value of data at a pharma company or at any company, right? Data is used to file IP, protect your molecules, protect your assets, right? And any time something prevents you from making a decision or prevents you from accelerating your project to the next step, right? That costs money, and it also costs patients quality of life, right? And so when we think about this, that isn't lost on us, the value of data at a company. And so a brief walkthrough of the agenda. I'm going to give you kind of the day in the life. What kind of software did I interact with? What kind of instruments did I interact with? And then to kind of take a step back and look at the totality of this. And I heard this often, right? Please don't make me learn another software. And just the amount of software and instruments it takes to perform the job of a scientist. And then the perils of Excel, right? A lot of people use Excel because it's super easy to use. You can do a lot of things really quickly, but then there's some downsides as well. And then I'll jump into what is TetraScience? How is TetraScience solving some of these challenges, helping people out? And in particular, I'm going to give this from a scientist perspective, right? I'm not a software engineer. I'm a scientist. What do I see about the platform that would have really helped my life at the bench? And then I'm going to talk about a couple of use cases. One around this design, make, test cycle. How can we make that easier? How can we facilitate going through the cycle? And then scientists love data, right? We love to visualize data, see data, make trends. And I think if you ask most scientists, right, this is the most fun part about being a scientist. And so I'll give you a teaser of how we can do that using the Tetra data platform. And so I want to start here, this picture of a mountain, right? Science is really hard, right? You know, to be a good scientist, to make an impact at a company, right? You have to have years of training. You have to know a deep amount in the scientific literature, right? You almost have to learn an entire language, right? A lot of people struggle with just understanding what you're talking about, and so it's really hard, right? And to get a molecule to the market is extremely challenging, right? All of the low-bearing fruit are already gone, right? And so to make a real impact in today's society is extremely challenging. And the way I think about it too is there's a series of mountains, right? Each step is its own mountain, and you have to keep climbing mountains. And so when you're a scientist, the first thing you might do is you kind of chart your course, right? And so I've drawn a line up this mountain. This is my hypothesis. These are the experiments I need to take to get to where I need to go. And so you can plot your course on the mountain. And then when we think about a day in the life, what as I'm climbing these mountains, what steps do I have to take to climb it, right? And when I was at the bench, right, the first step in any experiment, usually started in the ELN. So I need to write my objective. What am I trying to answer? What steps am I going to take? What data am I going to collect? And in particular, I was in a high throughput lab, so we did a lot of lab automation. So I would write something in my ELN. I then might have to go to a liquid handler, right? And my ELN didn't talk to my liquid handler, so sometimes I'd have to write a CSV file, right? And then upload that into the liquid handler, right? After the liquid handler, I might have to take those samples I generated and go to an HPLC. Again, my HPLC didn't talk to my ELN or my liquid handler, so it had no context for what samples I was feeding it, right? So I had to use an Excel macro or manually transcribe these, right? Once I ran those HPLC files, those HPLC analysis, right, I had to generate a report, batch process those files, and then put them back into the ELN. And so you can see at each point of climbing this mountain, there's friction in every step, right? It makes it even a little bit more challenging to do, right? And ultimately what I want to do is I just want to get all of this data so I can visualize it, make conclusions. Did I answer my hypothesis? Was my hypothesis wrong and I need to go back down and climb a different mountain, right? And so really what I'm going to tell you about today are some key things about the Tetra data platform that just ease the friction of all of these steps, make it easier to climb the mountain, give you the right tools to climb the mountain. And this is what really excites me. And when we think about climbing a mountain, there's a lot of gear, right? And I think this gear is really what causes friction, right? Because as a scientist, you're answering challenging problems. You really need to have a whole host of tools at your disposal, right? You need to have liquid handling. You need to have ELNs, built for purpose. You need to have analysis software, right? All sorts of different instrumentation, right? And this instrumentation, I think causes a lot of frustration for people, right? Because they have to learn all of these systems, right? And for example, like when I was in graduate school, I used an Agilent LCMS, but then when I started at the company, you know, we had a SciEx LCMS. So I had to learn a completely new software, how to create methods, how to load samples, and this friction is really challenging for people. And then, right, as I talked about this journey of getting my data from an HPLC into the ELN, how did I do this, right? I put it in Excel, and then I transferred it into the ELN. And really, Excel is the workhorse of pharma. I probably excel in PowerPoint, right? And we used Excel all the time to store results, right? We would keep adding results to an Excel file. We would show these at project meetings, right? And we assumed that this Excel was the version of the truth. And I was thinking about this, preparing the slide, and it made me think, if you gave somebody an Excel file with 2 columns, how quickly could a scientist make an XY scatter plot with a trend line, right? Probably 15 seconds, right? Because everybody knows Excel. It's the one tool everybody knows how to use. But as I mentioned, right, if you have Excel, and I think this is getting better, but how do you version control this? How do you make sure that nobody has tampered with your Excel file advertently or inadvertently, right? And I don't know how many times I've seen somebody's Excel file, and then I've wanted to either replicate what they've done or add data to it, or take that data and put it in a different visualization piece, and then you can't find it, right? Was it on SharePoint? Was it in a file share? Was it in Teams now? You know, it kind of can again add more friction, make it just a little bit harder for you to do your job. And there was this one time we had an Excel sheet. We were using it for part of the project I was on, and I sorted a column, right? And when I sorted the column, I didn't sort the entire table. And then I left for vacation, you know, thought everything was fine. I come back from vacation and find out I had made this Excel error. And in my absence, the team spent a week trying to replicate these results, right? And so the inability to really have a good audit trail in Excel is really challenging. And if you Google biggest, most costly Excel errors, right, you'll find a whole list of either financial firms who've lost money in this London whale incident, or even government. And in the case, the UK government used an XLS file instead of an XLSX file, and they undercounted COVID cases, right? And so this is fraught for error and for challenges. And now I'm going to go into the Tetra data platform. And again, what really excites me about this, and what I think can really revolutionize how a scientist can utilize all of these tools. And when we think about the Tetra data platform, we think about the world in 2 ways. There's data sources, so places where data are generated, and then there's data targets. So when we first think about the sources, the various sources within a company, there might be CRO or CDMO, and this is an increasingly common source of data, especially in this age of cloud computing. And you can think of a CRO or CDMO as like a cloud research organization. And then we have instruments. And when I was in the lab, this is, you know, a really common source of data for me. And then we could also think about informatics applications. You know, really the ELN that a scientist is using is generating data, right? It's generating their plan of record for how they want to execute their experiment. You could also think about, you know, emailing files to each other, or using some other informatics applications to generate data. And then we have sensors, right? What about pH meters, O2 sensors, even your freezers, right? And in the lab I was in, right? We would constantly have freezer failures, right? And you have to have a sensor on these freezers to know when they're losing temperature, so that you don't waste years and years of time and money with all of your samples in your freezers. And then we think about data targets. In a lot of ways, the ELN in LIMS is a data source and a data target, right? Ultimately, we generate results. We want those to go back into the LIMS and ELN. We think about data lakes and warehouses, right? I know a lot of companies have teams of data engineers, curating data, harmonizing data, adding metadata to various pieces of data and uploading them into their warehouse, like Hadoop clusters. And then we could also think about data science as being a data target, right? If we're not preparing our data so that data scientists can use it, we're really not extracting the full value of the data we're generating. And then we could think about my favorite data target as a scientist, right, was visualizing the data. We need to be able to easily get the data into our favorite visualization to make insights from the data. And then in an increasingly automated world, robots and control software is going to be an increasingly important target, right? We need to be able to send instructions from an ELN to a robot, be able to go to the robot, set it up, and then execute. And then get that data back, and I'll talk about that a little bit later. And when we think about mapping all of these data sources and data targets onto what the life of a scientist might look like in a lab, it's really a web, right? Where a scientist might use their ELN, create plates that need to be created in their LIMS. They might then need to go to a plate reader, right? Get those values from the plate. And potentially someone's wrote a custom script to feed those results back into their LIMS, right? You can start to see sort of the fragile nature of this, right? Where one LIMS doesn't have access to the ELN and vice versa, right? Limited access to data, point-to-point integrations, right? In that example, from the plate reader to the LIMS. A lot of manual transformation, manually moving data from one place to the other, and really an inability to analyze data in its totality, right? So we think about data silos. And when I see this picture, I know that in a lot of labs, there's a person who kind of holds everything together, right? It may not be perfect. It may work well enough for people, right? And there's that one person that kind of fixes everything whenever it breaks. What do you do when that person leaves, right? We live in an increasingly competitive job market, right, where people are being headhunted. What do you do if the person that supports your LIMS leaves? It can create a lot of challenges. And so what I'm going to talk to you about is the Tetra data platform. How do we go from these data sources to these data targets? And the first thing we do is we collect data from all of these different data sources, from these instruments, from these sensors, from your applications, and we move it onto our cloud platform, right? And then these can be collected through connectors or agents, and we can go into the specifics if people are interested. But once it's on the platform, this really opens up a huge potential to search the data. And this is something I'm particularly interested in, and we'll talk about it in a little bit. But if we think about breaking down these data silos, it really leads us to this utopia where we can search for files across all of our platforms, all of our different data sources, and really allow scientists to generate new insights, to not go down roads that have already been trodden, and really is an exciting time for us. And then we need to extract additional metadata. What instrument did it come from? Who ran that sample? A lot of these things really enable data science downstream. And then I'm going to talk about this again a little bit later, but the data has to be harmonized harmonized. If you don't harmonize it by first intent and you don't really think deeply about how you harmonize your data, you're really not going to be able to extract the full value from it. And you're really going to limit the scientist's potential to switch instruments, to change things. And then again, ultimately, this data is being used to make decisions. How do we make decisions? You know, we need to visualize the data. We need to be able to do data science and AI ML. Again, store the data in ELN and LIMS. And having all of the data on the platform, we can access it through either SQL or APIs, kind of the classic way that data targets are used to accessing this data. And if we have data that we can validate and enrich, we can validate it, enrich it. And I'm going to talk about this in a little bit, but for example, if we're uploading compound data onto the platform, we can check, oh, is that compound registered? Great. If not, we can send a flag. This compound hasn't been registered. What do you want to do? And once the data has been validated and enriched, we can, again, push it. We can automatically push data to, robots. We can push it to the data lake, data warehouse. Again, we can push it back to the LIMS. And when we think about this entirety from data source to data target, we call this, at TetraScience, we call this an integration, right? So we have a data source that's fully integrated onto the platform, and we're able to do all of these steps. And we have a really high bar for calling something an integration. And I'll talk about the number of integrations we have, but this really, you have to complete all of these steps in order for it to be called an integration. You have to be able to collect it. So we have to know, is this a file? If it's a file, how do we parse it, right? If it's not a file, if it's an API, how do we access the API to get the information out of it? We have to be able to capture all scientifically meaningful data. It's one thing to just store the file onto our cloud, but if we're really not understanding the context of that file and the data within the file, we're not really integrating or providing value to the scientists. And then again, the data has to be harmonized. We have to take the data from a vendor proprietary or text file and move it to something that's easily consumable. And we can go into this into more detail, but if you ever hear TetraScience talks, we have this, what we call an intermediate data schema. And then if you're not enabling data science, you're really going to be at a competitive disadvantage to others, right? And so having this harmonized data, having the ability to access the data really is an enabler. And then if we can't push it and we can't really facilitate the scientist's life, it's not really an integration. We've just enabled another data silo. And so unless you have all of these key pieces, it's not an integration. We don't count it as an integration. And as a scientist, it really gets me excited to see the amount of integrations the company has, right? And these are unique data sources, but do not necessarily count the total number of instruments. And so this is really thousands of instruments that we can integrate with. And really the true value of the platform is going to be maximized when we get all of the data in a lab. And you can see at the pace we're growing, this is going to be a reality in the near future, right? You can see by next year we'll have 250 different integrations. Again, probably covering another host of various instruments. Okay, now I'm going to go through a few pieces of the platform that I think, from a scientist perspective, are really going to add a lot of value to the scientist's life, make things easier. And one thing I'm particularly excited about is this concept of harmonization. And this is a really hard thing to do. It takes a lot of thought. You need to have the scientific context. You need to understand understand data architecture principles, right? And so we put a lot of time into how we harmonize data from instruments into this, human readable, machine readable format. And sort of when I think about this as a scientist, I was doing some experiments where, again, we would run HPLC, and we had a particular vendor of HPLC. And what would happen if those HPLCs broke and I had to move to a different vendor HPLC? I would have to either completely rewrite that point-to-point integration for the new HPLC, which was not possible at the time, or I would have to take those HPLC results, try to put them into Excel, figure out how I can extract the data from those result files, and then I would have to open the HPLC report that I would normally get, and I'd have to copy and paste the data into that new report so that I could complete my workflow and upload my data to the LIMS. And so you can see it's a really fragile system, but when you have harmonized data and we can get data from any instrument, right? It's simply just a change in a workflow, right? We're just going to change, that data is from an Agilent HPLC. Perfect. We'll use the Agilent harmonization, right? And we know that because all LCUV data is harmonized the same, that you can still look at it the same way you would in your visualization and your downstream applications. And this is something I think is critically important for the life of a scientist. And then we have validation and enrichment. And when I think about this, I think of the times where I was typing in samples into my HPLC sequence, right? And maybe I mistyped something, right? And then I would try to push it into our LIMS system, but I had it mistyped and it would send an error, and I would have to go back and really manually try to identify what the problem was. Because we validate it on the platform, right? We can understand, we can check all of those plates. Oh, does that plate exist in your LIMS? Okay, great. Now it's been validated. And this validation and enrichment, I think, will give scientists a huge amount of confidence in their data, right? Recently we've been calling this, Tetra approved data, where it's been validated, it's been enriched if possible, and I think that's a really interesting value proposition for the life of the scientist. And then when I think about what I used to spend so much time on, I used to spend so much time interfacing with my ELN to get results, from something like HPLC over to the ELN. Finding out, what instrument did I run it on? Where was that file pointer? What method did I use? What's the method file? All of these things, and then either transcribe it into the ELN or get those files and post them to the ELN. And when we think about a Tetra data platform paradigm, right, we'll easily be able to tell what experiment did this come from? What LIMS does this need to go into? And just automatically push the data back into the LIMS. So when the scientist opens up their notebook again and they refresh the page, right, they'll already see the results. Oh, it looks like everything already came through, everything's finished, now I can do the next step. And we think about, again, an increasingly automated world, right? We're gonna have automation, right? We're gonna be using liquid handlers, robots, right? We're gonna be able to push those instructions to the robot based on what you wrote in your ELN. And if you have a data warehouse, right, we'll be able to push those results there as well. I think this is really a transformational paradigm shift in how data is managed. And I said at the first collection step, search. I think the ability to search an entire organization's data in one place is going to make it so much easier to generate insight, not go down these roads that people have already gone down. And when I think about it in this paradigm of climbing a mountain, right, we'll be able to know all the other routes somebody took to get up the mountain. You know, we'll know, oh, that route was really steep and had a crevice that they had to jump over, right? Oh, this route, this green route was a little bit longer, but there weren't any really bumps. And I think this is really going to be revolutionary. And when I think about it, especially as you increase the size of the organization, as a scientist, you would always hear these buzzwords, you know, data silo. And what does that mean? And I was trying to think of examples, but when you think about being at a large pharma organization, I would I guess challenge you to see if you can take a compound, find all of the high throughput screens that compound was a hit in, right? Go back into the discovery chemistry notebook and find, oh, what was the yield and purity of that compound? And then see, oh, is there any DMPK on that compound, right? And in a lot of organizations, these are going to be in different data silos, and you're going to have to search, you know, in each part of the organization. But using the Tetra data platform, collating everything into this R&D data cloud, doing this type of search is trivial, right? It's very similar to a Google search, and we can discuss that later if people have any questions as well. And the totality of this platform, I think, has a few very real advantages, right? Accelerate time to insight. Having the ability to search data, again, unlock insights, harmonize data, feed your data right into an AI/ML model and not have to have the data scientist spend so much time wrangling the data. Automatic integration, right? The scientists should just have to refresh their ELN to see their data. This is really going to improve the life of a scientist. And then new technologies, right? In this world of point-to-point integrations, when you change a new instrument, right, you have to redo that point-to-point integration. But with the Tetra data platform and with the harmonization, bringing on a new instrument is just selecting integration for that instrument, right? We take care of all of that for you. The open network of integrations we have are completely accessible to all of our clients. And I think is really going to add additional tools to the scientist tool belt, right? Did they come out with a new HPLC? Perfect. I want to buy that. I want to use that. Simple. And then again, gleaning deeper insights, making it easier for the scientists to see their data, make visualizations from the data, making it easier for data scientists to generate models based on the data. And again, we bring this back to the mountain, right? I talked about all of these friction points, right? All of the steps I talked about, ease the friction, make it just a little bit easier to climb this increasingly challenging problem of science and discovering medicines, making discoveries. And now I want to talk about a couple of use cases that I think are pretty neat. The first one, facilitating this design make test cycle, and then I just want to give you a taste of how you can visualize the data in the platform. So again, I think I mentioned it, but when we climb this mountain, we don't really get to sit at the top of the mountain and enjoy the view or bask in the glory of conquering this mountain, right? No, you need to take the lift back down, go back down the mountain, and then start again, right? And so this cycle of experimentation is what we call the design, make, test, analyze loop, right? We can think about it, which molecule are we going to make? What animal model are we going to use? Which cell line are we going to make? And then actually executing that, making molecules, making cell lines, running liquid handlers, getting all of those samples, all of those, batch materials, and then testing them, sequencing, HPLC, all of the instruments that are at your disposal. And then you got to join all of that data, analyze it. Which cell line was the best? Compare them to historical cell lines, compare them to historical molecules. How does this molecule fit in our SAR plot, right? And at each of these stages is a person, right? A person's taking the design and translating it into synthesis steps or liquid handling steps. They're writing their HPLC sequence, right? And again, these are the friction points that a scientist feels. And I know a lot of people picked up a hobby in the recent, I guess, 14, 16 months, bread making, right? We can think about, choosing a recipe, baking the bread, testing it, right? And then analyzing it. Oh, it was a little humid that day I made it. Maybe the next time I make it, I'm going to add a little less water. Go through these loops until you make the perfect loaf. And just to really show what this is like from the point of view of a chemist, right? You might be making different molecules to probe, anti-inflammatory effects in various assays. And what I'm going to show in the next slide is how TetraScience, again, decreases the friction, right? What if you had something that could automatically take your ELN instructions and send it to a robotic arm, right? And then all you'd have to do is go to this robotic arm and say, oh, I want to use the instructions from this ELN experiment, right? And then you would take all those samples, go to your HPLC, just select which sequence has already been populated, right? And then use the APIs, use the SQL capabilities to analyze your data. And when we take one more granular step, really this is what the platform is doing, right? We can use the ELNs, the LIMS as a data source, and then we can listen. We can see, did Joel create a automation run? Did Joel create a sample set in his ELN? And then automatically, because we know how the data are coming from the ELN and we know how to send the data to a HPLC or automation instrument, right? We can just automatically do that. And the same is true for the reverse, right? We want to complete the cycle. We want to automatically take the automation run, take the HPLC run, and upload that into the ELN. So all the user has to do is refresh their data and see if it's ready. And I think this is something I really wish I had when I was at the bench. And we can think about this, making it so that at some point, as we continue to increase the amount of automation, really it's just going to be somebody at the design step, right? Maybe we're in this lab of the future. Somebody creates a design and then just automatically kicks off the cycle, right? And enabled by the Tetra data platform, right? And then again, you get to spend more time at the top of the mountain looking at data, analyzing data, trying to, again, climb these increasingly challenging mountains. And then it wouldn't be a talk from a scientist without showing a little bit of data, right? This is, again, the scientist loves this part. And so using the Tetra data platform, and either its API or the ability to write a SQL query against the platform, you can build data apps. And these are kind of reminiscent of dashboards you might build or scripting tools you might use to analyze it. And so here, we can write things that monitor column performance over time. So peak K prime over time, right? You can see outliers are identified, right? Maybe if you saw an outlier, you could go to your HPLC, change your column or something like that, right? We can also dig a little bit deeper, right? So that was just kind of a data point from a particular piece of instrument, but we can actually look at a chromatogram, right? We can analyze the data in a little bit more detail and adjust peak retention and do other things that the next generation of scientists is going to be trained in Python and other tools to help enable these types of things. And then one thing that might look familiar to any chemists in the audience, but this SAR plot, can we have all of the data in the platform automatically update an SAR plot, right? And so here I'm showing data on the platform, queried using Elasticsearch and visualized live, is essentially in this screenshot. And so with that, again, I hope you'll take away that science is hard. All tools should make it easier. And the Tetra data platform and its ability to get data from a source to a target really is one of those tools that makes it easier. And so with that, I thank you all for listening, and I'm excited to hear what questions you'll have.
Great. Thank you very much, Joel. Much appreciated for a great presentation. A couple of things. We'll go ahead and get the recording stopped.